Let's go ahead and do another physics problem. A plane's average speed is 192 kilometers per hour. If the airplane lands at this speed and accelerates at negative 1.68 meters per second squared, how long will it take the plane to stop? All right, so let's kind of visualize what's going on here, because that's the first thing we want to do. So I've got a plane flying along in the air, and it's coming in for a landing. Let's say this is the tarmac or runway. So it's going along at 192 kilometers per hour. And what's important here is to realize or identify where a problem actually begins and where it ends, because sometimes that can be a little area of confusion. So again, we're flying along at 192 kilometers per hour. And when we just touch down on the runway, guess how fast we're going? 192 kilometers per hour. And then we begin to slow down, slow down, slow down, slow down, slow down, stop. So our problem here doesn't begin when the plane's in the air. It actually begins when the plane just touches the runway. So our initial velocity when the plane just touches the runway is going to be 192 kilometers per hour. One more thing about that, kilometers per hour. Our equations don't take kilometers per hour, they take meters per second. So we're going to have to do a little dimensional analysis and get that into the form that we can actually use. All right, well, let's go ahead and draw a diagram of this. Now that we kind of know, we can picture this in our brain, let's go ahead and make a simple physics diagram out of it. All right, so again, I'm going to model the plane as a point mass. So there it is. And this is the plane when it just touches the runway. And then it slows down, slows down, slows down, stops. So the final velocity is going to be 0. The initial velocity is going to be 192 kilometers per hour. And I am going to change that into meters per second. And I also know the acceleration. So the acceleration is going to be negative 1.68 meters per second squared. And notice that my velocity and my acceleration have opposite signs. The velocity is positive, so that's the direction of the velocity, right? That's what the positive sign tells you is the direction. So let's make that the positive direction. And my acceleration is in the negative direction. And because they're in opposite directions, this plane is slowing down. If this acceleration was positive, and this was positive, then the plane would actually be speeding up because both of those quantities would be in the same direction. But here, they're opposites, so plane's slowing down. Now let's see what else we have. We're looking for the time. So how long does it take to get from here to here? That's what we're looking for. So before I even decide to choose an equation, I'm going to go ahead and get this into its proper form. And I'm going to use dimensional analysis. Now this is how we usually write 192 kilometers per hour. But I'm going to go ahead and I'm just going to write it in a slightly different form, a more useful form. So here I go. So I got 192 kilometers per 1 hour, because that's what that actually means. That means the plane travels on average 192 kilometers each and every hour. Now I don't have to put that over 1 because it's already in the form of a fraction. So I'm good. Here's a conversion factor. But I've got two things I need to convert here. Kilometers to meters and hours into seconds. Now it doesn't matter with which unit I start with. I'm going to start with this one. I'm going to work from top to bottom. So I want to get kilometers into meters. Now I got kilometers on top, so that means in my conversion factor, I need kilometers on the bottom, so kilometers cancel out. All right? That's not up for debate. It has to be that way. So I know that 1 kilometer, and again, I put that on the bottom so the units cancel out, equals 1,000 meters. So now my kilometers, not my kilometers, my units cancel out, not my numbers, not my value. Now I'm in meters per hour, but I want to be in meters per second. So now I got to work with the hours, so I need another conversion factor. I've got hours on the bottom, that means I need hours on the top so that those hours cancel out. So I know that 1 hour equals 3,600 seconds. Now my hours cancel out, and I'm in meters per second. So again, I multiply everything on top, 192,000. I multiply everything on the bottom, 3,600, and then I do my division, and then that's my answer in meters per second. So in this case, it works out to be about 53.33, so on and so forth, meters per second. Now I've got everything in the right form. I've got everything in the right form. So now I got to go ahead and I've got to pick an equation. So the equation I'm going to choose for this, again, my equation must have time in it. So I could identify, the handful of equations I've got. I could identify the ones with time in it. Put a little check mark next to them. I've kind of narrowed things down already. And then out of those equations that I've narrowed it down to, which of those equations also has the other information that I have available? Because not every single equation will, but at least one of them will. All right, so let's go ahead and use this equation. Average acceleration equals change in velocity over time. And whenever I see change, I know really in disguise that means what? Final minus initial, or initial, right? But I'm going to go ahead and I'm going to rewrite it anyhow, just to keep me honest so I don't make a mistake. Final minus initial over time. Now I can go ahead and I can substitute in. All right, my acceleration is negative 1.68 meters per second squared. So again, what that means is I'm losing 1.68 meters per second of velocity each and every second until this plane comes to a stop. Equals, the final velocity is 0. The initial velocity is going to be 53.333, so on and so forth, meters per second. And I'm looking for a time. And remember, time has to be positive. And it's going to work out to be positive. I got a negative here, I got a negative here. 2 negatives are going to give me a positive. Right? So I want to get time all by itself. So and I want it in the numerator too. So I'm going to multiply both sides by time. Time cancels out here. I got time times this equals negative 53.3. So I'm going to divide both sides by negative 1.68. Negative 1.68. This cancels out, and I got time equals negative 53.33 divided by negative 1.68. That gives me a positive time. So my time is going to work out to be 31.7 seconds. 31.7 seconds. I'm going to put a box around my answer. And that is going to be it for this problem.